right, coming up next is a tech speaker for Mozilla and a developer at HSBC Technology India. Here to speak about creating web-based VR experiences with A-Frame. Everybody please welcome Shagufta.
So good afternoon, everyone. Before I begin anything, I'm just going to ask two simple questions. How many of you have ever built an application on virtual reality? Great. And how many, okay, I shouldn't really ask that question. I'm standing at a JavaScript conference, but I assume almost every one of us is a web developer. So the aim of this session is to make the count of these two groups equal. A little about me, as he already said. I'm Shagufta from Pune, India, and I'm a tech speaker for Mozilla. I have been contributing to Mozilla for some years, and I started working on A-Frame some time back. I passed out of college in 2016. I'm currently working as a software developer at HSBC. So, going by the definition, okay, this was supposed to be a video, but it's not playing, but never mind. Going by the definition, virtual reality is a computer-generated simulation of a 3D image or environment, which can be interacted with in a seemingly real or physical manner by a person using some kind of electronic equipment like a headset. So basically, it transports you to something very realistic and immersive and 3D environment. And it's the next platform. It's going to completely change how we interact and play and live and work and communicate digitally. You could have seen some awesome stuff going on in the background. So these guys need some headsets for doing that. Now, there are different kinds of headsets available in the market. All of them differ in their complexity and functionality. This is like the first one is Google Cardboard. It costs around $5, and it provides a very basic functionality. It's a mobile VR headset which uses the gyroscope of your phone for motion sensing, and it gives a low FPS and a basic functionality like some 360-degree images and videos and basic click functionality. On the other hand, the last one is HTC Vive. It costs around $800 and it has some two controllers, two base stations for motion sensing, which you keep at the diagonals of a room, and it can detect complete room scale tracking. It gives excellent frames per second and field of view, but it needs to be connected to a PC with a very high processing power. But that said, the worlds and experiences created by it are absolutely mesmerizing. But the problem for developers is that there's a lot of friction in the VR ecosystem. What I mean is that there are a lot of gatekeepers. You have to go through. You cannot just publish an application and share it like, hey, I built this. You want to check it out? Yeah, you cannot do that. Because you'll have to go through a lot of approvals. You have to fit a certain criteria. And app stores and corporations, they control distribution. They can take down your content. They can block it. And even if you go through these procedures, you'll have to make others download your application. And for them, it's a complete black box. They don't know what's going on inside. And speaking of downloads, you yourself will have to download a lot of big softwares, huge installs, complex setups. You do not want to do that because it makes your life terrible. And it's a closed ecosystem, proprietary engines, steep learning curve. You might have to learn a new language probably and spend some time figuring out how to make it work with multiple headsets. And siloed experiences, fragmentation. We want VR to be successful, right? So we want a platform which removes these points of friction. And the answer to that is WebVR. WebVR allows web developers to create fantastic cross-platform, cross-device applications, VR applications. Quoting from a talk in Google I/O, VR should be accessible to everyone because it has the potential to let everyone play, explore, and create in amazing new ways. Developers should be able to build something quickly and share it with the world, just like no matter what device they are on, like how easy it is to share stuff on the web, but with VR. Well, that is the very idea behind WebVR. It's VR on the web for everyone. Developers can create something just like they create the regular websites with web technologies. Okay. Sorry for that. And it has all the advantages of web. It's open. Anyone can publish. It's open source with open standards. Connected, sorry for that. Connected, it's, you can traverse worlds and scenes with just like hyperlinks in 2D web. And instant, just click on it and bam, you're there. No installs at all. It's basically a JavaScript API for the browser, which enables WebGL rendering to the headsets and access to VR sensors. The initial WebVR API was by Mozilla. Now there's a working W3C community group behind it. And Mozilla, Samsung, Google, Microsoft, all of them are currently implementing WebVR 1.0 API in their browsers. These are the browsers that support WebVR currently. And mobile polyfill, it uses the smartphone, the mobile motion or device sensors, orientation sensors to polyfill on smartphones. Firefox, I forgot Firefox here, Firefox 55. Firefox was the first browser to fully support WebVR. The concept of metaverse is shared, persistent, collective virtual spaces and alternate digital reality in which the world might live and work and play in. But to achieve that, it has to be completely decentralized, open, and connected. And like we remember from Lewis's talk yesterday, he was talking about creating augmented reality marker-based application with Three.js. Well, can we make it more accessible? Because it is still too hard to create experiences with Three.js. You need to import WebVR polyfill, set up camera, lights, initialize the scene, VR effect, render loop, etc. There's a lot of things. These things are a huge obstacle if you are just looking for creating some small experiments and a beginner experimentation, some small prototypes. You don't want to write thousands of lines of code just for the initial setup itself. So, and the boilerplate code, all these things, they need updation with the new versions of WebVR, Three.js, and browser quirks. So, what if we could encapsulate all of this, like all of the boilerplate code, into just a single line, just one single line? Well, introducing A-Frame. Now, A-Frame is a web framework for building virtual reality experiences. It's an open source framework. It's built on top of Three.js, and it allows developers to create, web developers to create virtual reality experiences, VR content, without graphics knowledge. You can experiment and explore web VR and VR UX faster. It's basically a kickstart to the web VR ecosystem. And the best part is that you can write some simple applications by using just simple plain HTML. Now, all of us are web developers here. So obviously we all know HTML. And even if someone doesn't know HTML, generally speaking, someone did not study it in high school, how much time does it take? Some few hours, that's it? So it's super easy, right? Of course, for advanced applications, you might have to write some JavaScript for registering the components and writing the logic. But that's about it. We have our very own web technologies to use to create some very powerful experiences in web VR. And of course, you get unlimited access to whatever goes behind web VR. Now, remember how I said about encapsulating everything in a single line? Well, a scene is the global object that does it for you. All of it, camera, renderer, loop, VR effect, web VR polyfill, everything just magically in one line, and you do not have to put any extra effort, any extra code. You can just concentrate on building the real stuff, the actual business logic, and while using A-Frame, this script tag is all you have to put. No build steps as such. So let's put stuff inside our scene. Now I've just added some primitive elements that are provided by a scene, like a box, a cylinder, a sphere, a plane, for creating a box, cylinder, sphere, and plane respectively. Sky is the sky, the surrounding world, any color or 3D image or something. So components in A-Frame are like CSS tags. We have color, position, all the parameters for X, Y, Z axis. We can just provide it like that. So look at this piece of code. It is so readable. HTML is arguably the most accessible language in computing. And it is like encapsulated. You can copy paste this piece of code somewhere else, and it will just work. No state or variables as such. Now let's see what this produced. So with just 4 lines of code, we have a VR scene, although a very basic, but that was about it. That's all we needed. So we are already one step closer to the metaverse we talked about. Now, this is an A-frame scene embedded in my HTML slides, and I can just open up the DOM inspector and change the values also. Now, because this is based on HTML, so it works, it is compatible with all your favorite existing libraries and frameworks, D3, Vue, React, Redux, jQuery, Angular, everything. This is really a very good reason to have HTML as an intermediary layer between WebGL, 3JS. And under the hood, A-frame is an extensible declarative framework for 3JS. Now, A-frame is an entity component system architecture. Those of you who have worked on Unity might be aware of it. It's particularly used in that. It's a famous and a common and desirable architectural pattern for 3D and game development. So it favors composition over inheritance and hierarchy. So all objects in a scene are basically entities, which are inherently empty objects, and components can be plugged into them to give them some appearance, behavior, and functionality. In the 2D web, we generally lay out elements in which have a fixed behavior in a hierarchy. But in 3D and VR, things are completely different. Objects can be of infinite types and complexities, so there's a need of an easy way to build up objects. And ECS, Entity Component System, allows for a greater flexibility while defining objects by reusing and configuring reusable parts, mixing and matching them. And it removes the problem of long inheritance chains with complex interwoven functionality. And it promotes clean design via decoupling, modularization, encapsulation, and reusability. So for example, in this image, we have, this is an entity, and it is the base of all objects in the scene. It is a container object, basically. And by itself, it does not render anything. It's kind of like an empty div tag in HTML. But we can attach components. These are the components. They are reusable modules or data containers, which can be attached. And they'll add the appearance, behavior, and functionality to the entity. For example, we have geometry. Material geometry must have some shape and radius, etc. parameters. Material will have its own parameters. We just keep adding components and build up the entity to the behavior we want. If we look at this is a ball. It's an entity. It has a geometry of a sphere, maybe a material. If it's a football, some particular kind of material. If we add some light, a shining light, it'll become a glowing ball. If we add a sound, it'll become a singing glowing ball. If we add the explode component, it'll become, so basically the point is, we can compose entities by plug and play. And it's like you can just take and mix and match and configure. It's like alchemy. You can just compose anything you want. For composing an entity in A-frame, you require an A-entity tag. And as I said, it does not have any appearance of its own. We can plug in components to add appearance, behavior, and functionality. And the syntax here is similar to CSS styles. The component names are as HTML attributes, and the values are as HTML attributes values. We can add position, rotation, scale, all the components, whatever component we want to add to give the particular behavior to that entity. We can just keep adding it. Animation, movement pattern, these are all the components in A-frame. So you can specify all kinds of components. A-frame has, these are the components that ship out of the box in A-frame. There's a huge community of developers which are continuously working to make it, to improve it, and there are a lot of users that are using the awesome stuff. And the developers have filled the community ecosystem, with a lot of components. These are, the ones in blue are the components developed by the developers. And the component ecosystem is basically the lifeblood of A-frame. You can find anything: physics, leap motion, particle system, audio visualizations, oceans, everything. You can just take them and drop them as script tags in your HTML application, and you can just use them straight out of HTML. These are the advanced developers who have been helping empower other developers. And the registry is a curated collection of these components. It's like an asset store, a free asset store. You can just go and search and install components. For installing, as I said, you just need to include the script tag. So, for example, this was again supposed to be a video. It is a leap hands component, and if you want to use it, you just include the script tag and use the entity, add the component in it, and you'll get two hands with actions for listener or whatever you want them to do. Okay, yeah, A-frame has a shortcut, keyboard shortcut, that allows you to inspect, basically inject the inspector. It gives a completely different view where you can see the visual effect of tweaking entities. So if you open any A-frame scene, this was something I had built for my mother on Mother's Day. If you press Ctrl-Alt-I, you get a completely different view. This is like the VR analog of the console that we have, web development console. And you can just tweak the entities, you can move stuff here and there, and you can add components onto it and see how it looks. So yeah, that's the inspector. Okay. Okay, there's more. So you have JavaScript events and DOM APIs which we can use to programmatically change the entities or the scene and its entities. You can do stuff. You can have the development console, just like normal web development activities we do. So this is JavaScript. You can use all those silly little things like query selector all to get a reference to the scene and its entities. You can just set attribute to modify and configure those entities, and you can create elements on runtime, set attribute, configure them, and append them to the scene, to add them to the scene. For example, you can just, in a JavaScript for loop, you can add 50 A-box elements and just randomly position them and scale them. There's add event listener. You can just add an handler function, which will execute when an event is emitted. So A-frame, of course, has a way where you can add 3D models. This is a view of Seattle. It's blurry because it's smoky right now. And this is a 3D model that I have added. So models, as you all know, that come as text files, plain text files which contain the vertices, animations, faces, UVs, etc. And they also come with images for textures, which generally come along with the model files. And 3JS loaders, what they do is they parse these files and render them onto scene as meshes. And A-frame model components, they wrap around these 3JS loaders basically. So if you want to do this in A-frame, it supports all kinds of 3D models like Wavefront, OBJ, Collada, GLTF, etc. All you have to do is pick up that particular component for the particular type of model and write this one line of code, and you have it there. I mean, you just need to specify the path, and you can keep adding components because, as I said, it's an entity. You can build up the entity as per you want. You can change the scale, position, rotation, add as many components as you want, and there you have it. So A-frame has a huge community, as I said. aframe.io/blog is the blog where they keep updating. There's something known as a week of A-frame, where they publish all the featured applications every week. If you've developed something interesting, if you've developed a game, or something like that, you can just share it on Twitter and tweet @AFrameVR, and you'll probably get published, get featured. These are some great applications, my favorites, that people have built with A-Frame. So there was something known as Google Tilt Paint, which allowed you to use your controllers and paint in virtual reality. So A-Painter is a clone of that to show how powerful A-Frame is. And you can, as we can see, it can just allow you to use the controllers and do whatever you want. This was something built by someone for showing a tour of what's happening in Syria, basically. Journey to Mars. And this is a game, which is a city builder. You just pick up stuff and put it there, like general city builder games. Interesting. Data visualization, this is my personal favorite. You can just put on your headsets and there's this beautiful visualization. You can add multiple dimensions and variables onto your graph, and you can view the visualizations in 3D. This is something really interesting and useful. Gaming A Blast, basically you have to target some innocent mosquitoes. So gaming applications have also been built in A-Frame. Prototyping, it's definitely very, very useful for prototyping applications. When you really want to try out what your product will look like, you can try out in virtual reality and then experiment in reality. Mathematics, this is like plotting some graphs in 3D and calculations, everything in virtual reality. AR.js is a framework for building augmented reality applications using A-Frame. So this particular one in the video is a marker-based augmented reality application. AR.js uses AR Toolkit and 3JS for allowing you to create applications in A-Frame very quickly and easily. So it's still not so mature yet, but there has been great progress, and you can definitely try it out. There have been tools built on top of A-Frame, so WebVR Studio is one of them. It's not completely developed yet, but it's for Mac, and it allows you to just drag and drop and build A-Frame, build virtual reality applications using A-Frame. It uses A-Frame internally. You do not have to write any code for it. This was supposed to be a real estate live tour, so you can just view your home before you buy it, probably. Just a virtual 360-degree images. Education, well, of course, this is really very useful if you're a student studying for becoming a doctor or something and you want to experiment, but you're not really allowed to do it to a real human. You can do that. You can do that here on this virtual reality, on this human. You can do anything you want. So if he has to do some surgeries of hearts or something like that. So it's very useful, actually. So aframe.io has around in fact, it has increased now, 180 contributors on GitHub and a lot of stargazers, members on Slack. There have been interesting conversations going on Slack. And there are a lot of featured projects, very useful and interesting again. So I would definitely recommend you all to check out the documentation. I think the creators of the documentations attended Kim's session on What the Doc because it's really useful, beautiful, and exhaustive. And there's only so much I can say in 30 minutes, but yeah, you should definitely check out the documentation. Thank you for having me at SeattleJS.